Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we will solve question that was asked in JAM 2008 paper, which is based on infrared spectroscopy. So the question is, the metal carbon multiple bonds in metal carbonyl are preferably identified by stretching frequency of. Okay, so let us first try to understand what exactly is a metal carbonyl. So there is some central metal, okay, central metal atom or ion. Okay, let's say we take some atom having some charge, okay, central metal ion. Now what happens is carbonyl, if you see the structure of carbonyl, it is like this. Okay, so what exactly happens is this carbon lone pair, carbon will donate its lone pair to the central metal atom. Okay, that is how a sigma bond is formed. And then what exactly happens is a back bond will also be formed. There will be multiple metal carbonyls, okay, not just one carbonyl ligand. Let's say it is octahedral complex. So in octahedral complex there will be how many CO ligands? There will be total of 6 CO ligands, right? So there are multiple CO ligands. So what exactly happens? The electron density on metal is much higher. So what it will do is it will donate the electron density back to the empty vacant orbital, or you can say vacant LUMO of the carbonyl, which has got some anti-bonding character. So that is why what happens is anti-bonding character. So what happens is the metal carbon bond becomes stronger. Initially it was single bond, now it has become double bond, and carbonyl bond strength decreases. It was triple bond, now it has become a double bond. So after back bonding, what happens is, okay, this concept is very important. After back bonding, what happens? The metal carbon bond strength or bond order increases. Metal carbon bond strength or bond order increases, and carbon oxygen bond strength decreases. Bond strength or bond order decreases. Why this decreases? Because whenever you add a electron in anti-bonding orbital having molecular orbital having anti-bonding character, it is what anti-bonding molecular orbitals are, what they are higher in energy. Okay, they are higher in energy, so they are what, they are less stable, or you can say they are unstable. Okay, they are unstable. So whenever you add electron into this, what happens? The bond order will decrease. Okay, because they are higher in energy. So what exactly here we get after back bonding is metal carbon double bond is formed, and carbon oxygen triple bond has now become double bond. So you can see in IR spectroscopy what exactly do we find out is, I told you we see a, what we require is a polar bond, okay, where there is change in dipole moment that is possible. Polar bond and change in dipole moment is possible. Okay, so here you can see which bond is present. Carbon oxygen bond is the polar bond. Okay, what are the options that are given? Carbon oxygen bond, metal carbon bond. Metal carbon bond is not very polar, so that is the incorrect option. Metal oxygen bond, so you can see there is no direct bond between metal and oxygen. Okay, so this is also incorrect. T, carbon carbon bond. Okay, carbon carbon bond is non-polar, that will not show any that will not be seen in infrared spectroscopy, and it is not present here in metal carbonyls. Okay, which bond is present? One is metal carbon linkage that is present, and carbon oxygen linkage that is present, right? So the infrared spectroscopy is because of the which bond is identified. It is the carbonyl bond that is identified, that is carbon oxygen bond. Okay, either it can be triple bond, or if back bonding is present, then it will be carbon oxygen double bond. So the correct answer for this question will be option A. Okay, so one more important point is stretching frequency of metal carbon bond is greater than that of carbon oxygen bond, right? Metal carbon stretching frequency increases, carbonyl stretching frequency decreases. And if you talk about the bond length, Okay, bond length is inversely proportional to the stretching frequency. So bond length of C double bond O bond, this bond will be greater as compared to C metal carbon bond. Okay, as compared to metal carbon bond. So the correct answer is what? Correct answer will be option A. Okay, correct answer is option A. I hope you have understood the solution. Thank you.